Hey guys, so today we will be graphing rational functions. So that just means that we are dealing with a function of the form f of x equals p of x over q of x. So we're dealing with this fraction, and p of x are polynomials. But q of x cannot equal 0, so we can't just have a 0 on the denominator, which we know we can't divide by a 0. So that's the only restriction we have on that denominator. So there are 4 steps to graphing. First, we want to simplify the function. So that just means that if we can factor, we're going to factor, and we're going to cross out things that are both on top and on bottom. Then we're going to find the x-intercepts, and that just means we're setting the numerator equal to 0 and solving. Then we'll find the vertical asymptotes by setting the denominator equal to 0, and then we'll find the horizontal asymptote using the rules below. So the rules written out in this table are not my favorite way of seeing the rules, but I'll write them here in the table so you can have them, and then we'll go over how I remember the rules. So if the degree of p, the one on top, is greater than the degree of q, remember the degree is the highest exponent. If the exponent on p is greater than the exponent on q, then we do not have a horizontal asymptote. If the degree of p is less than the degree of q, so if the bottom exponent is greater, then we have a horizontal asymptote at y equals 0. And if their degrees are the same, then we will take y equals the coefficient of p over the coefficient of q. So this is just to fill in the table. The way that I was taught to remember this, and I still use to this day, is Bobo Botten eats DC, which sounds really ridiculous. So for my horizontal, we use Bobo Botten eats DC. So this first B is bigger on bottom, means y equals 0. Bigger on top, none. And exponents are the same, divide coefficients. So the degree is bigger on the bottom, y equals 0. The degree is bigger on the top, we have none. And if the exponents are the same, then we'll divide our coefficients in order to get what the horizontal asymptote is. Oh, and I said there were 4 steps, but there's a 5th one. The 5th one is to identify any holes in the function, which we'll talk about right now. So a hole in a function is a point where there's a break in the graph. So that means we could have this straight line all the way across, but somewhere on that straight line we don't have a value there. So a hole occurs whenever we are simplifying. If there is a common factor that we cross out, then we have a hole there. And so the x-coordinate we'll find by solving that factor equal to 0, and then the y-coordinate we'll get by substituting into the simplified function. If we substitute it back into the original function, we're going to get an error. We're going to get something that doesn't exist. So just be aware that when you are plugging that back in, you're going straight into the simplified version. So we're going to start with number 1. We're going to graph the function and then identify its key characteristics. So first thing we want to do is check, can this be simplified any further? We have x minus 4 over x plus 4. Neither of these can be simplified. They don't have any common factors, so we'll just leave it the way that it is. First step, once we've checked if it needs to be simplified, is to find our x-intercepts by setting the numerator equal to 0. So for my x-intercept, we'll take the numerator, set it equal to 0, and solve it. So x is equal to positive 4. Remember that my x-intercept is a point, so 4, 0, which we can go ahead and put on the graph. Then the next step is to find the vertical asymptote by setting the denominator equal to 0. So my denominator is x plus 4. So x equals negative 4 is the vertical asymptote. And remember, these asymptotes are lines that we're going to get infinitely close to, but we're never going to touch. So we will have a line where x equals negative 4. The next step is to find the horizontal asymptotes. So we have a degree of 1 on top and a degree of 1 on bottom. So that's each DC. Exponents are the same, so we'll divide our coefficients. Y equals 1 over 1, which is just the line y equals 1. So we have a horizontal asymptote right here. And then I also like to find the y-intercept, which we know we find by putting a 0 in for x. So 0 minus 4 over 0 plus 4, negative 4 over 4, which is negative 1. So the y-intercept is 0, negative 1. So my y-intercept is right here. And then we're going to look for any holes. So since we did not have to simplify, then we don't have any common factors between the top and the bottom, so we will have no holes in our graph. And so I know that my graph is going to go through these 2 points, get infinitely close to that line, infinitely close to that line. And then with our rational functions, they're on opposite ends. So we've got one in the upper left corner and then the one that we graphed from the points on the lower right. And then from here we can write our domain and our range. Now our domain, our x values, are going all the way across the x-axis except where x is equal to negative 4. So at that vertical asymptote, we don't have any x values. So we write that as negative infinity all the way to negative 4, not included, union negative 4 to infinity. So if we did have some value at negative 4, we would put a bracket on it. But since we cannot use negative 4 at all, we're going to put the parentheses on it. And then same thing for the range. Our range goes all the way across the y-axis except for where y equals where y equals positive 1. And so we go down from negative infinity all the way to 1. And then we start again right after 1. So that's what our graph would look like on number 1. we're going to do number 3 as well. First thing we want to do is simplify. So on number 3, we've got x squared minus 1 as our numerator, which we know is a difference of squares. So we've got x plus 1, x minus 1. And so here I can see that I have x minus 1 on both the top and the bottom. So this would simplify to be just x plus 1, which means we're going to have a hole somewhere. So on number 3, we're starting with our x-intercept. X plus 1 is equal to 0. X is equal to negative 1. So I wrote that over to the right, and then I put it on the graph. And then our y-intercept, we'll get by plugging in a 0 for x, so 0 plus 1, which is 1. So right here, we're going to have a point. And then we will find the vertical asymptote. So with our vertical asymptote, we have to set the denominator equal to 0, and we don't have a denominator. So we're not going to have a vertical asymptote. Horizontal asymptote, we find by the original function, we've got x squared over x. So the square is on top, that means we're bigger on top, which means none. And then we're looking for where we have a hole. And in order to find the x value, we'll take the factor that canceled, set it equal to 0, and solve. So x equals 1. And then to get the y value, we'll plug that into our simplified function. So we get 1 plus 1, which is 2. So our hole occurs at 1, 2. So then on our graph, we'll go to 1, 2, and we've got this hole. Now we don't have any asymptotes, either vertical or horizontal. And my new function, when it's simplified, is x plus 1. X plus 1 is a line. So I have a line with a slope of 1 and a y-intercept of 1 with a hole at 1, 2. So then my domain, my x values, will be everything except 1, because that's where that hole is. So we start at negative infinity, go all the way up to 1, and then from 1 all the way to infinity. Then with our range, same thing, but we're starting from the bottom of the x-axis, the y-axis, and we're going all the way up, and it looks like we're covering everything except where this hole is. So that hole makes our range go from negative infinity to 2, and from 2 to infinity. Next one is number 5. On number 5, we've got 2x squared minus x minus 1 over x squared minus x minus 12. So we are going to factor both the top and the bottom to find if we've got any holes. So on the top we have x minus 1, 2x plus 1, and then on the bottom, x minus 4, x plus 3. And so none of them are canceling out. We don't have the same on top and on bottom. So we don't have any holes, and we can't simplify. So we'll work with what we have. So for our x-intercepts, we are taking our numerator and setting it equal to 0. And so we will have more than one x-intercept on this one. So we have an intercept at x equals 1 and x equals negative 1/2. So we'll write that in. 1, 0, and negative 1/2, 0. Then the next thing we're looking for is our vertical asymptote. Vertical asymptote we find by setting the denominator equal to 0. So x would equal positive 4 and negative 3. So we'll draw those in. Positive 4 and negative 3. So we have two vertical asymptotes. And then our horizontal we find by the degrees. They are the same, so that's each/dc. We'll divide the coefficients. So y equals 2 over 1, which is 2. So y equals 2, we have a horizontal asymptote. We have no holes since nothing canceled out. I'm going to draw this in. And then we'll write in our domain and our range. So for our domain, all of our x values, we can see a couple places where we're stopping. So we go from negative infinity, and we stop right at negative 3. Then we go from negative 3 and stop at 4. And then from 4, we go on toward infinity. Then for our range, we stop once on our range. So you go from negative infinity all the way up to 2. And then from 2 on to infinity. And then the next one that we'll do is number 9. Number 9, we're going to factor the top and the bottom so we can simplify. So x squared minus 4x minus 5. We have x minus 5 and x plus 1. Denominator, we have a 2 in common, so we'll take it out. We've got x plus 1. X plus 1 is both on top and on bottom. So leaves me with x minus 5 all over 2, which looks like a function that I wouldn't know how to graph, but that's 1/2 times x minus 5 over 2 when you split up that fraction, which that looks like a line. So we're going to have another function that once it's graphed, it's going to look just like a straight line with a hole in it. So we'll find our x-intercept. by taking our numerator and setting it equal to 0. So at x equals 5, we're crossing the x-axis. Then our vertical asymptote by setting our denominator equal to 0. 2 equals 0 cannot happen, so we have none. Horizontal asymptote, we've got bigger on top, since there's a degree of 2 on top and then a degree of 1 on bottom, which means none. And then whole, since we crossed something out. If x plus 1 is the factor that was crossed out, we'll solve that for x. And then we'll plug in a -1 into our simplified function. We've got -1 minus 5 over 2. -1 minus 5 is -6. -6 divided by 2 is -3. So our whole occurs at -1, -3. It should be right here. And then if we wanted to, we could find the y-intercept to help us graph. This is not required though. So y would equal 0 minus 5 over 2, which is -5 over 2. So the y-intercept is occurring at -2.5. So then I'll just fill all this in here. Our x-intercept is at 5, 0. We don't have either asymptote. There is a whole, and -1, -3. And then we said it was going to look like a straight line. So I'm just going to connect that as best as I can. And then the domain and range. Our domain are x values. Go from -infinity to that whole, which occurs at -1 on the x-axis. And then keeps going. And then our range goes all the way up to that whole, which occurs at -3 for the y-axis. And then keeps going. Oops. So then the rest of them are for you all to graph. There's only 5 of them that are left. I think, let me double check before I say that. I've done all the ones that will simplify to a line. So there are no more that will look like a line. The rest of them are going to look like number 1. Yes, the rest of them look like number 1. So find each part of your graph. If you need an extra point in there because you're not sure, then find your y-intercept and see where that's occurring, because that can always help you determine what direction these lines should be headed toward. So this was just day 1, and then we'll continue graphing our rational functions tomorrow. So make sure that you get these 5 problems completed and then turned in on Canvas.